So as she said, I'm the project lead and a data scientist at IBM, the giant corporation. Here's a list of some bona fides if you're interested. So I currently work with US federal clients, right now the Department of Commerce, and I've worn a bunch of hats. I've been a data scientist, a information architect, a bunch of other things, so that's why I didn't put the titles. Previously, I was at the OECD for a bit in the Directorate of Public Governance. I was working on illicit wildlife data modeling, and so if you want to find a great niche where you can help a lot and do a lot of good, and also where all the data is terrible, look at illicit wildlife trade. It's really sad, but it's really interesting. And then as Nino mentioned, among other things, I was at Jumpstart Georgia in Tbilisi for a bit. And that's actually the job and working with a lot of the people who are now at Foresight. That set me towards more of a technology direction. I have a bit too much education. As you can see, I have a master's in IT from Carnegie Mellon. I did a master's in technology government at Tallinn University of Technology in Estonia, and I also did a master's in public policy and management with an emphasis on analytics at Carnegie Mellon. So before I jump into the real meat and potatoes of the talk, I want to talk about this word AI, which it's very much a buzzword. I don't want to use it in a kind of a weak way during this talk, but it's actually not the emphasis of the talk. The talk is about metadata. And so when I talk about AI, I really want you to think about the type of AI that you're doing or you want to do, whether it's AI ML, or you're thinking about doing prediction or categorization or deep neural networks, whatever it might be. That's what I mean. Not so much about automation of processes. This is about data-driven AI, because what I'm going to talk about applies to any sort of data-driven analytics and AI sort of project or way of going about it, both individually and also at the team. So I just want to be that clear. I'm trying to use it in a meaningful way, but I literally mean everything except automation when I say AI. The structure of this talk is I'm going to talk about the problem. I'm going to talk about metadata a bit too much, and then I'm going to talk about metadata versus this problem. Okay, so AI typically involves lots of waste. So when you, in presentations and in the literature, when you do these projects, you spend a lot of time, it's been measured to be about 80% of your time doing what's mostly considered low value work. So, data cleaning, data wrangling, trying to understand what's going on before you move into this high value work, the modeling and getting the results and really like getting, the satisfying part of working with the data. So this is actually a really big problem, or actually it's three problems that this creates. So the first one is that too much of our work in AI is spent validating, cleaning, and wrangling data. It's just very labor intensive. It's very manual, and it's costly. And we kind of just treat it as something that doesn't create a lot of value. We want to get to the good stuff, right? The next problem is that too many AI projects are not repeatable. We do these whole projects, we spend a lot of time and effort on them, and at the end, when we go to the next project, even using the same data set or similar methods, we can't really transpose it over. And then the third problem, the big problem that the talk is about in larger terms, is that too much AI data are hard to understand. And this is because most data sets aren't created with AI in mind. They're doing other things. They're coded in different ways. The data owners have a specific use for them that they're designing them for and structuring them for. It's probably not going to be AI. Sometimes it is, but mostly it's not. So the outcome of this is that it increases error in the end because we don't understand the data. And it also decreases our connection to reality in qualitative terms. So maybe we build the pipeline and we run the model and we've got a really great error rate, but it has nothing to do with reality. And that's a really big problem. We like to say garbage in, garbage out. My counter claim to that is that all data is garbage. Like there's always going to be problems with your data. So how can we reduce that and reduce the amount of manual work we put into it so that we actually can use and retain the meaning of the data to then understand it better and make our AI outcomes better? So I'm going to say the 80%, that's where we got to look. That's the answer. So we need to treat this part of the process, the manual part, the data cleaning, the data wrangling, the banging our heads against the walls. We need to think about this as a high value part of the process, because this can help us with our goals. So our goals, and to refer to the problems I just stated, we want to work less, we want to waste less, we want to reuse our assets more, and we want to understand our data better, because that leads towards better AI, both in outcomes and processes reusability. We're not wasting as much. So how do we do this? Metadata. So here's definition number one: data about data. This is a common definition. It's very literal of what metadata means. This is kind of what you see and you hear, and there's variations of it. It's a terrible definition. It doesn't give you any information. It doesn't give you any sense of what metadata is or what it can do. It's also kind of weird grammatically, at least in English, because data is plural, and I don't like it. So we're not going to use that one. We're going to dive a little bit deeper into it, but I don't like it. This is my definition of metadata. So metadata are assets that increase data meaning and usefulness. And the word asset is actually a really great word in English because it means an object, it's a thing, and it's also a thing that's useful and beneficial. So metadata should be things that are beneficial that then increase what the data means and how much it means and its usefulness. So getting a bit deeper into it, there's actually, for me, there's a big difference between these two definitions in terms of structure and also function, right? And so the data about data, and I'm going to do a little demo here in a second. You have your data set, and you don't understand something, so you go looking for it, you find it, you come back, but you're not really using these metadata that you're going and looking that are helping define your attributes and other parts of your data. They're just kind of out there, right? When you treat metadata as assets, it's connected to your data set, and so you start to build out a network of data that adds meaning to your data, as you can see in this wonderful graphic I made. And it's also functional. And I mean, it's useful, but it's also, you can write code that actually uses your metadata in your AL projects and pipelines. So it actually has like a technical function when you treat data as assets. So first I'm going to talk about data, which I don't like, and I'm going to talk about assets. The thing I'm going to say about not having a good view about metadata when you go into AI is that you're going to end up needing to make data assets. So you might as well start with the assets. So earlier this year, I worked on this pretty big project where we were looking at ship location data. So the AIS system is run out of the US government to show locations for different vessels, ships around in the US coastal waters. The data set we had is a real mess, about 3.5 million rows, all in CSVs. So we had to do a lot of merging and a lot of, just that part of it was difficult, but we actually were able to automate a lot of it because I work with smart people. But the real struggle up front is what does any of this mean, right? So we can guess things like X and Y, probably Latin long, SOG, no ID, COG, no ID, MMSI, no idea. And then you can see underneath it, there's different possibly codings or their real values. There's a lot going on here, and we don't know what it means. So part of my job, and if the browser doesn't show up, going in Edge today. Hopefully you can still see Edge. So my job was to go and find these things, right? And so, you go to the source, you click through things like, there's a data dictionary, but it's a PNG, so I have to type it all out. Different things, and I've done this a bunch of times, so I know where things are. So for example, this is a nice thing because the US government is actually giving me a link to metadata. That's not always the case. But then, you're going to go and you're going to see like it's not structured. It's not always useful. They're making an effort to do it, but it's not great, right? And so I know where the thing is that I want. But eventually you find something like, okay, well, maybe this is going to give me some tables or some JSON or something that I can actually use. So let's look at the vessels, and it's great. It gives me the name, the type, the description. Wonderful. Let's say I want to know what MMSI is in more detail. It's got some more data on this attribute. So I found the metadata. It's great. now I have to scrape this website or pull it down in some other way. I have to structure it. It takes me a long time, but it's part of the process. So even though approaching this from not a robust asset-based way of doing metadata, maybe I would just look up what MSI is, say like marine mobile service identity. I change that in my CSV file and go on my merry way, but I've lost a lot of meaning, and there's a really good chance I'm going to have to come back and do this again and again, and people on my team are going to have to do it again because there's other attributes, and where if you're going to enrich your data or use other data sets, it's just it's not a best practice to treat it as piecemeal. So back to the presentation. So this is another data set. I haven't used it, but it's really fun. It's drug consumption data, and as you can see, this is how it's coded in a very impossible to understand way. And with a lot of data sets, especially coming out of older systems, the coding's not going to make sense. And so you have to find some sort of metadata to make it make sense. So this is by necessity. So, and this is a real fun one, let me tell you. So this comes out of the UCI machine learning repo. It's a really clunky website, but the data are actually really wonderful, and it's fairly up to date otherwise. So coming down here, let's just do age. These are coded. The values correspond to ranges of ages in cases in some fraction, whatever that means. This is just a coding they discovered. And then me as the data scientist or data engineer or information architect, I've got to go in and figure out how to format this so that it can then be an asset that we map to the original data set, which is meaningless to us without this. So all that to say, treat your data, metadata as assets from the get-go, and you're going to create things that help a lot more downstream. So I'm going to talk about more specifically into metadata data assets. All right, so this is the same ship data as before. This is a glossary that I put together. It's pretty, it's not exciting, right? These are tables. It's metadata is typically in tabular form, not always. It's the world we live in. And then you just find out what things mean. But the fun part is, as we were building this, we were building a geospatial prediction model using a convolutional neural network. And there was an ask for a client for it to be the end result to be very explicit about things. So we couldn't keep things in the original coded form. They wanted useful information at the end. They wanted high level of accuracy, low error, and it to be very useful for their analysts. So what that meant is we started looking at vessel type, cargo, nationality, and status in earnest, which are all coded in their own unique way. So we created more tables. And by we, I mean me. And these tables, and some of them, I created further metadata tables as reference tables and to show hierarchies and structures within the data, because we wanted to retain all this meaning. And that's really what you're doing through these assets, is you're retaining a lot of the meaning that you don't have in the original data set. And further downstream in this project, we set it up so that the UI at the end was mapped to these reference tables that I made. And so it was actually reading, vessel type, cargo, nationality, et cetera, from the metadata assets into the UI at the end. So in addition to the AI, machine, that this intelligent process we built, we're actually able to use these other assets in a really meaningful and wonderful way that the client really, really liked, because they understood it. And we understood the data because we did this. So there's really 2 points when this happens, right? So the first upfront part of this, this 80%, this is like detective work. It's kind of fun. It's kind of frustrating. I enjoy it. Some people hate it, but you're really digging into data source in the data itself to find out, like, what does it mean? And then how can I create assets to help my team and to help this process, this AI project? And there's a bunch of examples of these sort of assets. I'm not going to define them. But the point is that you create these so that everyone else downstream can actually have them ready at hand for understanding the data, because that's going to help them and it's going to help you as you're driving towards modeling and results. The second part, where metadata assets should be created, but not always are, is actually during the AI processes and events. So as you've loaded you've ingested the data, you're doing pre-processing work, you're running it through some, you're merging, you're doing post-processing, you're running into the models, you're doing the modeling, et cetera, the whole pipeline. There's actually a lot of further metadata that you are generating and that you should capture. So this can be, data catalogs, glossaries. Semantic assignments are really interesting because it's linking terms. There's ways to automate this. They're not that great, but it's possible. Lineages are great, just knowing where your data is coming from, so you can audit it. And there's others. This is a bit more technically difficult, but it's really rewarding. It's a great corpus of assets to build. So moving towards like how metadata helps solve these problems. So just starting with these assets is going to lower this 80%. It's going to lower the amount of time and resources you have to put into data cleaning and wrangling and all that stuff. It's going to enhance the amount of time you have for modeling because you're treating the whole process as high value. And so it reduces the work and the waste and increases your understanding, right? So next, if you can create these assets and then reuse them, this is fantastic. This is what you want to aim for, because if my team was using this ship data, the AIS data, another team's not going to be able to reproduce our end result. They're not going to want to. We already did it, but maybe they want to use the same data sets, and we made available with an IBM Federal not just the data sets and our code for the AI pipeline, but also all of these metadata assets and a lot of documentation around it. So when the next person uses this data set, they don't have to go and do all the detective work. They actually can understand it faster. And this just speeds things up. Because the reuse and the understanding are going to scale out. And then the last great thing is that automation of this will eventually just metadata asset creation use is just going to be reduced to around 0. It's all going to be automated. But unfortunately, this just doesn't exist yet. So that's I've taken you on this journey, and now I have to disappoint you because the technologies just don't exist yet to do this. There's some that kind of do it. I'm not going to talk about them during this talk. If you want to talk about them in Slack, I'm happy to. But it's frustrating because it should exist by now. It's 2021, but it doesn't. So we're still forced to do a lot of manual work. That will eventually be automated, and we won't have to spend our time doing, this quote unquote low value work. We're going to be able to just model and push results, and it's going to speed up the whole process. It's going to be great. So someday we'll do it. But in the meantime, here are my recommendations for all your AI projects, all your data-driven projects. The first is make metadata assets. It's just really important to all the work that you'll do. Every single one of these projects should have it. It should be at one of the first things you do when you start exploring the data, is start thinking about how you can create tables, or if you want to work in JSON or other data structures, that's fine. Just think about making metadata assets. And then the second thing is make metadata assets available. And this is both on your team or to those who you're working with, just so it's easy for them to find, or make it available publicly. So dump it in, a public GitHub or Google Drive or, whatever internal repo you have, so other people can access it. I'm sure thousands and thousands of people have used this AIS vessel data, and no one's just dumped a simple data dictionary on GitHub or online. I didn't even do it. I should do it, but I haven't. It's just something that it's going to save other people and other data scientists and AI enthusiasts a lot of time to do this. And then the last recommendation, if you have the skills, scripting skills, and you can program, just automate all the boring stuff. Move this towards being an automated set of processes. Where you see there's a problem, just write some quick scripts, and then importantly, share your code so that others can build on it. Think about, on internal to your organization or your team, think about how you can make this code available, but then also if you're able to, make it publicly available, so that others can use it and have more of the open source mentality, so they can build on it and tweak it, and it can grow into a thing. So that is all I have on metadata and AI. Thank you all for listening.